Hello, everybody. It's 7:59 p.m. Central Time on the 13th of July, 2023. It's Thursday night here in the United States. Hope you're doing well. It's Friday, going into the weekend already. Internationally, hope you're ready to have a good weekend, or at least try to make do of what's going on. Let's go ahead and turn on a display capture. A lot going on in the world, in case you didn't know. Got a lot going on, seismically speaking. However, we don't have any extremely large earthquake activity to report yet. Our largest earthquake in the past 2 days, almost 3 days ago now, 2 days ago, here in the Eastern Caribbean, north by northeast of Puerto Rico, out here beyond the edge of the Caribbean, technically in the Atlantic, or north by northeast of Barbuda and Antigua, I think is where it's listed from the USGS or the Australian, several of the agencies carrying the information. I will get a USGS map open. They have it listed as 6.6, which is somewhat odd for the USGS to be the topping out of the bunch, but I want to show you where it is on the USGS plate boundary map down here to the east by southeast of the plate. So out here along the edge of the whole plate, we have a big earthquake. Now, where did it come from? Well, we have to go back almost 3 weeks. 3 weeks ago, there was a 6.4 to 6.6, which struck right over here in Mexico. And you don't see it here on the screen. Again, it was a few weeks back. It was right here. So first, we had a 6.4 to 6.6 here in Mexico, and it took 3 weeks for that shift to come down, go over, and reach out to the mid-Atlantic ridge. I'll take you back over one more time and show you the spot that moved. First in Mexico, then down, then over. And as that shift took place, we saw an outbreak of fires that was incredible across central Mexico, going over to the Yucatan, as well as new volcanic blasts at Fuego and Santiaguito, and then, of course, Popocatépetl. That's constantly going to volcano there, but the spread was pretty obvious. There was something going on across this area, and now we have the big break. Same size, exact same size, from Mexico over to the east. And that's where we started out with the big earthquake a couple days ago. Then there was all this news that came out about the solar storm. Ooh, spooky, the solar storm. Oh no. Radio blackouts. Oh no, it happens every time there's a big solar storm, guys. Radio blackouts is expected. There's charged particles going across the upper ionosphere. Radio waves, high-frequency radio waves, going through the same area, they get reflected back down. And actually, shortwave operators actually like the skip that happens on some of that. But anyway, so what happened? Well, they said there was going to be northern lights that came down over the lower 48. Then, about a day ago, all these stories came out and said, whoops, got it wrong. You just can't make this stuff up, guys. So everybody went bonkers, overload, about the northern lights and the big coming solar storm from the X-class flares that also sent charged particles towards Earth. Well, I don't know what happened to the charged particles. I don't know about their projection and why they got it wrong. This is all in the mainstream. All the solar forecasters are, they're kind of justifying their getting it wrong. I'm not blaming them. The forecasting gets things wrong, as I have done. Well, we can go back to last week. Okay, so we were looking at an example of getting forecasting wrong, so to speak. Looking for a big break here in Japan, and looking for a big break over here at Afghanistan. And what took place? No big break at both spots. Now, the other 3 spots got hit. We warned 5 areas. 3 of the 5 got hit, and the 2 that didn't, now look what's happening. Here we are a few days later, and we have a big break. The deep earthquake raised high off the planet here, and up above it, a bunch of 5s going all the way across the coast of Japan. So, just a few days beyond our warned time, all of a sudden, Japan breaks. Let me show you what broke over in Japan. You see all these earthquakes here on the USGS page. Well, they go from Philippines all the way up to the coast of Honshu, just south of Hokkaido. Okay, that's what the USGS shows. You have to add in a few more from yesterday, and this is 48 hours worth of activity. It's pretty obvious. We've moved all the way across the area we were expecting to break with a single earthquake, and instead we had one down below and a bunch up above. If you add all these together, it equals about a 5.9 or so. Now, this deep 5.2, we have to watch for a shallower, larger earthquake to come up next to the deep 5. Now, I'm going to zoom in on it, and it's on the letter D. So, what's next to the letter D? Well, let me zoom in and show it to you here on the USGS map. Letter D is right about here. Well, right next to it is our H-shaped plate boundary that connects over across into Tokyo. Also goes up along the coast and back up into Russia and beyond all the way to the North Pole. Well, anyway, we're going to watch here at the H-shaped plate boundary for a 6.2. Okay? Right in the middle of where all the rings are overlapping. I would consider this a partial earthquake forecast hit and a partial miss. Again, if I'm looking for a 6 point something to hit here and instead a bunch of 5s break out and it happens a few days beyond when I'm looking, okay, that's the break we're looking for, but it's just not quite as big as I was expecting. Again, if I'm looking for a 6.5 and instead a 5.5 hits, that's one magnitude less than what we're looking for. Now, what else happened? Well, going on down towards New Zealand, let's take a look. Well, we had Wellington in the warning, and Wellington got hit, but it was a bunch of 3s. So right now, as it stands, my warned areas are one magnitude under what we were expecting. Pretty much across the board, from New Zealand all the way to Japan, I'll say it, that's one magnitude less than what we're looking for at each area. And that's good for you guys. Bad for me on forecasting. Where's the extra magnitudes worth of energy? Now, it's not just one magnitude missing. It's one magnitude across the area from Japan all the way down to New Zealand. Well, then that means it's a lot of energy that's missing. It's not just a little. We're one magnitude at each spot across 10,000 miles missing. Let's go back to the USGS map and look from Japan all the way back down here to New Zealand. You see it now, the red line. Red line connects between Japan, and those are the plate boundaries, between the Indo-Australian plate and the Pacific. And that's where we have the energy trapped right now. That's where it's going to break, and so we have to look for one single larger earthquake to break in the middle of all this, between Japan and New Zealand. And that puts right down here into Indonesia. Oh, 1 second, guys. 1 second. Got a little sneeze. All right, sorry about that. Okay, it is the season to be a sneezing. Now, for me at least, middle of the summer, I'm always sneezing. I don't know what's going on. Anyway, let's go back down across over into Australia, where now you have your near 4.0 level activity down next to Perth, down at the southwest side of the plate. And this follows all that other activity you had down over by Melbourne, at the center of the plate over by Uluru, and like we were looking for, a break down in the southwest, about the same size. And we can trace it all the way back to the to the arrow that goes back up to the north. X is all the way down here. We'll get to that in a second. But anyway, going down to the south by southwest, down to the south by southeast, and it all goes back up to the arrow. Now, as for this X, guys, we have some activity that's been taking place over here, southeast of Africa. That goes out by Mayotte, over east next to Madagascar, and it's been strangely quiet. No seismic activity worth mentioning down here at the X, going back up across the Indo-Australian, middle of the Indo-Australian plate on this ridge. And this ridge had previous extremely large earthquakes back in 2012, I think, or was it the end of 2011? Anyway, 2012, somewhere in that time range, 2 mid-range 8s struck here. A few hours apart. No tsunamis. This was side-by-side movement going north and south, most likely. I don't really know which way it shifted. I just know it didn't shift up or down because there was no tsunami activity reported with it. It was just huge earthquakes as this thing shifted. Well, anyway, I'm going to watch all the way down here at the X in the middle of nowhere. I know nobody really cares, but this X in the middle of nowhere is really at the tip, northeast tip of Antarctica. And the giant 5-sided star fort-shaped plate that makes up Antarctica. And the spade symbol, where in the middle is the physical South Pole. Do you see it? It's not pareidolia, delia. This is really the plate boundary. It goes around the outside edge of Antarctica. And this really is a giant spade-shaped symbol, which really does have at the very center the North Pole, or I'm sorry, the South Pole, depending on what time of century it is, or what century it is. Not what time of century it is. What century it is, it might be North or South Pole. Long story on that. Anyway, we're right out here at the pinnacle tip of this thing, and that's where we're going to watch for a new break to take place. Could be big. Could be big. Luckily, it's out in the middle of nowhere. And if it does happen, it may produce some kind of tsunami activity, but it would go out more towards Antarctica and maybe affect Australia if a big tsunami were to happen. But again, when we get into that 7 to 8.0 range, just out there, it's iffy. If it would go side by side, you don't get a tsunami. I'm not going to say there's going to be a tsunami on this. I'm just saying there should be a big quake out here in the next few days. Okay, what else is going on? How about up here in Russia? All the way up here. Now, you guys may or may not know about the Russian submarine base up there. You got to say it like that, by the way. The Russian submarine base. Now, I don't know if the USGS is carrying this quake. Hold on. Let's go see if we can get coordinates from somebody. Okay, there we go. There we have coordinates finally. Let's get those. These come from Geophone Potsdam. That's sufficient. There we go. Now, the Russians had a submarine base up here along the land. Now, I don't know what's going on out here on this island. I would think it's something to pay attention to because, again, when you get in here and you got the submarine thing going on, I don't know exactly where the sub base is. I just know it's here somewhere. They've got a bunch of coastal radar stations that are also based out of here. And big fuel depots. Okay, you know the military's operating there. Anyway, this spot tends to melt a lot. Get a lot of melting going on in the ice out there. I just don't know why. Back before they shut it off, you used to be able to look at this thing called the cryosphere today to show you the ice pack. They turned it off because it debunked global warming. They did. No joke. We had sites that we could see the ice pack on a regular basis and not forecast ice pack. I'm talking you can actually see the stuff. And the mainstream media was saying the North Pole was melted. And me and a few other people put out videos showing the cryosphere today, showing the actual North Pole completely frozen over. The mainstream media had to come out and say it was an Olympic-sized pool of melt or something they showed in a picture or something. Anyway, they shut the site off, so you can't see it anymore. But you used to be able to see. Back when we had technology back in 2010 and 2011. You Zoomers now don't have, you know what I'm saying? It's for your own good. Anyway, you used to be able to see the melted ice up here when they would melt it. They would melt it how? Radio waves. You didn't get out there with a heater and melt the ice out the other way. You're not using icebreakers to melt the North Pole. What? They can use radio waves to melt ice? Uh-oh. Okay, anyway. Yeah, they can use a microwave to melt ice, yes. Yes, giant microwaves can melt ice, yes. Okay, let's go and look at the rest of the earthquakes going across the plate boundary. Look at 48 hours worth of earthquakes coming out of Asia, going across over to Afghanistan. You'll notice it's the same size quakes, within a hair of a point of each other, all the way over to the Gulf of Aden, going over south of Saudi Arabia and Yemen, and going out across over into, like I said, Asia itself, into China. It's all the same size, like within 1 point of each other across 5,000 miles. And what is that? Let's go back to the USGS map and show you what moved all the same size. 5,000 miles across Asia to Afghanistan, down to the Gulf of Aden. What is that? That is the northwest side of the Indo-Australian plate, all shifting on a 4.5 basis in a couple days. That's what it is. So, obviously, we're shifting on the north side of the Indo-Australian plate. We're going around the outside edge on the north side with 4s. We're going up on the north side towards Japan with 5s. I think it's pretty obvious which way the wave is trying to prefer to north, going up into Japan. However, when we get a flex between here And here, we tend to see the break somewhere on the edge or in the middle of on the edge or in the middle of the plate. And that gets me back to my warning down here for the X. So we're going to be moving on the Indo-Australian plate. I think down here at the X, on the south side, we're moving all the way along the north side, going up around this way. We're going up to Japan. Stands to reason, should break on the south side. Now, going over towards Europe, check this out. Would take a step down. But it's about the same size. We go from 4.5s down to 4s. And 4s over the past few days went across all of Europe, around the outside edge, up through Romania, up through Poland. You guys got that earthquake activity? I hope. It's not on the screen here now. I can't even show it to you. It's about 2-3 days old. 4s went around the outside edge of Europe. Now we have 3s going up into Italy. So 4s going around the outside edge, 3s going up into Italy. We look between the 4s and the 3s, where all the rings overlap, for something bigger. And I have a warning that has 2 more days go in Crete going to Rhodes down here. Actually, 1 more day to go. Today is technically day 7, so we'll give it till tomorrow. But warning issued 7 days ago, and nothing hit. So it expires very soon. Looks like I got it wrong, but I'm not going to say I got it wrong until tomorrow and get a last day kind of thing. If it doesn't hit, we have to figure out where the 5.5 went, where the energy went. 4s going around the outside edge doesn't justify, if I'm looking for a 5.5 down here or something bigger, and we only get 4s going around the outside edge, then there's energy still trapped in here. And no duh, right? Like, look at it. Last 2 days, you can see it's a big ring of energy around the plate boundary going up into Italy. Let me show it to you on the USGS map. So a bunch of earthquakes going up in Italy and back around and right through here. Now, previously, we went around through Romania, up through Poland, and that gets me to Iceland. Eruption! We saw a new eruption. This volcano was dormant for 6,300 years. It came back to life in 2021. It erupted, made the news, went dormant for a few years to 2022. It erupted again last year, and now it's erupting again this year. So 3 times in 2 years, this thing's gone. It was dormant for 6,300 years. So let's go take a look at it, get the information on it. 5.1 at Alftanes. Alftanes. Now begin the American pronunciations of Icelandic words. Let the fun commence. You ready, class? You're about to learn how not to say something, which is almost as valuable as learning how to properly say something. Now let's just back it out and take a look. Iceland. Iceland. There's Fagradstjärfall. I can't. Come on, man. Now look, you're also going to see we're going next to Trollingenia. I cracked the joke about this is where the 9-year-old army of YouTube trolls live. But now you'll see we're far north. Let's get a measurement on this and just see where the seismic is coming in relation to the eruption. We are 60,000 feet. In miles, that's 11 miles. And in kilometers, that is 18 kilometers away. So it's definitely related to the volcano down below. The magma chamber is shifting. It's good releasing content. There's all kinds of videos that you guys can go search on social media. Every one of them has a little copyright stamp down below. Everybody's trying to frickin' cash in. I don't blame them. If I was there, I'd put my little Dutch Sense logo on the bottom and put a copyright on it. Go ahead and take it. Go ahead and try. I'm like, dude, all right, you guys got it, man. You got it covered. So if you want to go see all that, you can go check it out over on any social media site. Search Iceland eruption, and you'll find a bunch of drone videos and people there that waited. They were camping out like waiting for iPhones. Icelanders were waiting with their tents. A bunch of hippies, Icelandic hippies, so I guess they just have slightly longer hair. Slightly longer hair, and they're definitely not wearing Birkenstocks, though. They're all wearing North Face. Anyway, they're out there and they're doing their thing, waiting for the volcano to erupt. And they were not disappointed. It erupted on the north side, the north flank. A new spot broke open as the magma chamber shifted. We were looking for that to happen as the seismic wave went around the outside edge of Europe. Now let's go over into, hold on a second. Aloha! Aloha, Mr. Hand! I'm dating myself by mentioning that quote there. Yes, I probably have that water bubbling device here somewhere here in my office. I got to do my homework. We're here at Hawaii. Let's go take a look. There's the expected earthquake. It just hit. When did it hit? 21:29 UTC. What time is it now? It is 1:13. It hit about an hour ago. Just under an hour ago. A 4.5. The expected earthquake. Check it off the list. Earthquake forecasting hit for Hawaii. Let's go get the coordinates, put it in, and see how far off I am from the warned spot. I had warned at Kilauea. So we need to measure from Kilauea out into the ocean here and just see. I'm trying to get it within 200 miles. This might be more than 200. I'll still call it a hit. There's Kilauea. Hey, no, we're at 160 kilometers, which means 99.9 or 99.19 miles. We're 99 miles. I got 99 problems, but earthquake forecasting is not one of them. Real bitch. Okay. Anyway, there it is. There's our expected 4.5. We were looking for it to go up to 4.5. So we'll see if they alter that up or down magnitude-wise. The reason we were looking for 4.5, 7 days ago when I issued the warning, we traced this back up to the north, which goes back here, makes a hard bend to the far north like an arrow and points into Kamchatka. Kamchatka is the island here. It belongs to Russia. We're looking for the same sized earthquakes that came up, out, and went across to also go down and over into Hawaii. So what size was coming up, over, and across? In my video 7 days ago, I talked about it, 4.5. And now here it is, 4.5. It took a week for this to happen. Now, what really happened over the course of 7 days? A wave vibrated up, back down, up, and back down to Japan, and finally vibrated down here on day 7 into Hawaii. A very low frequency wave bouncing around through here, and you can see where it's bounced back and forth. It's dropping off the earthquakes. Along the way, as it reflects back into itself, it builds up like a standing wave in a tank. For those of you who understand what standing waves and tanks and all that stuff. Basically put, a wave comes up, gets reflected back into itself, and when it gets reflected back into itself, as more waves are coming in, it builds up in power. We'll go from 4.0 up to 5.0. We'll go from 5.0 up to 5.5, and so forth. Keep going back up as the wave pumps into itself, as the standing wave grows in power. As it grows in power, it spreads, or tries to, and when it spreads, it pops up between the current sets of waves. Like a true standing wave, comes up between the previous waves. So, the halfway points are hit between the previous earthquakes. Standing wave principle. Big discovery. That's a huge discovery to find out that earthquakes come up between the previous sets of earthquakes because there's a wave bouncing around in there, and the standing wave principle. Wave comes up between the other previous wave, reflected back into itself, gets stronger, more magnitude, more amplitude. Hawaii hit. Check it off the list. I'm going to come take over. They might imprison me, though. Dutch versus the volcano. I better bring some luggage. Floating luggage. Toss me in. Yeah. You toss me in, the thing will go out. It won't explode. The volcano will go dormant. It'll freeze over. And we're going to go over into the United States. Let's go down into let's go into the lower 48 first. We'll talk about Alaska in a second, because really, if you just take a look at Alaska, you'll see the earthquakes marked in white, or whitish color there, happened in the last day, and white and pink. And the earthquakes down here happened in the last day. And if you look at the magnitudes, you should be able to tell they're the same size, within a hair of a point of each other. Just a little bit bigger. up in Alaska itself. Why is that? Look at the plate boundary map. We got 4s up here, or upper 3s and 4s, and we got mid-range 3s, and that's all across the plate down here to the south. Now, down on the south side of the plate, we've got this. The Craton. I don't have a delay, so I have to just do that with my voice. Too lazy to download the delay thing, you know? Echo. The Craton, take a look at it. You can see there's the same size earthquake up in Alaska that there are going across the edge of the deformed Craton down in the United States. And this is another huge discovery, that the wave flows along and around the Cratons. This wave that drops off the earthquakes. So take a look at it. Who got hit? It's pretty obvious. Supervolcano, oil pumping operation. Now, how do I know there's a supervolcano with those two spots and an oil pumping operation there? Well, I've been looking up earthquakes a long time. I've got all these areas memorized, but I will prove it to you by looking them up for you. And then we're going to look up the smaller earthquakes, and the smaller earthquakes connect between the bigger earthquakes, like a stepping stone path, literally. Let me show you. Oh, wait. There we go. So here's the last 2 to 3 days worth of quakes, and I just showed you the 3s. Here are the 3s, right? Now look at the 2s connecting between, and now the 1s connecting between. And my internet just was shut off. Wow. My internet was just killed here at my end, but I'm still recording. So if you were watching live on Twitch, you literally just lost your view. It just died on live. I mean, I'm still recording. I'm going to upload this to YouTube. Oh, I'm reconnected all of a sudden. All of a sudden, my internet is back on. Now, you know, you can't even unplug a router and plug it back in that fast. Like, you can't just turn your internet off and then back on. That's wild. Dang. What was I just talking about? Oh, yeah, the Craton. The connection of the earthquakes. Huh. Big discovery. Everybody denied it. Why did they deny it, right? You could see it. Why did they deny it? They said I was adding the earthquakes in here to make it look like there was a progression. That's what the professionals said 9 years ago when I tried to show them. They freaked on me, man. People still freaking on me, obviously. Whatever. Okay, anyway, line of earthquakes goes down across the edge of the North American Craton, goes over to the east. We expect this to happen regularly. It's a regular thing to happen. And the spread is dictated by this wave that's going across the plates. So let's go look them up. Like I said, we have 2 supervolcanoes and an oil pumping operation. Let's turn the magnitudes back on. We'll start up here in Idaho. I think we already have the info. Or, well, not Idaho, I'm sorry, Montana, side by side, Idaho and Montana. This is Yellowstone. This is right next to where that sulfur train derailed into the Yellowstone River. Yes, a sulfur train, a train carrying molten sulfur and liquid tar, accidentally spilled into the Yellowstone River 60 miles north of Yellowstone National Park. It's just by chance. That was 60 miles north, I'm sorry. We are 60 miles west where this current earthquake is. I'm not saying they're related. I'm just saying they're right next to each other. Look, you get a train derailment right here, and then 60 miles west of the park, we get a significant earthquake that's bigger than the rest. And when I say significant, it's not huge. It's a 3. Don't get panicked. Now I'm going to zoom in on the spot, and you'll see there's a stack of earthquakes there, not just one quake. There's a swarm of earthquakes there west of the park. This is a change from where we were. We were previously at the park, in the park itself. Here, over to the east, where this swarm of earthquakes is. Now, swarms of earthquakes are somewhat common at Yellowstone, and you get hundreds of tremors per day. But these are earthquakes. These are actual cracks above the magma chamber. So this new addition of a 3 and an outbreak to the west of the park, when we had the train derailment just north of the park, and then you've got the swarm going inside of the park. Now, I told you the other spot out to the west is also a supervolcano, here at the California-Nevada border. Make note of the magnitude up at Yellowstone, 3.3, and the magnitude here over on the edge of the Craton over to the west at Mina or Mina, Nevada. Now, one more time, craton diagram, purple part. Look at California. See that point? The purple part that comes in at a point into California. Remember where that is. That's right at the California-Nevada border, Central California. Just remember it, because we're going to go back over and show you what's really there. I'm going to put the earthquake in there. Earthquake coordinates. Should take us right there. That's where the earthquake is. Mina, Nevada. And supervolcano I mentioned, right? There it is. Long Valley Caldera. 1,000 cubic kilometers of melt down below, classifying it as a supervolcano. Right across the border is where the quake is, over here at Monte Cristo. And here are where those old quarries are. Here's the deal, kids. Back in the 1700s, back in the 16 and 1700s, the Spanish got out here and did an open pit mine quarry. This is where they invented the process. And they were looking for something. And they abandoned it all. And then wagon train people coming from the west found it, and they were perplexed, and they didn't know who dug them. And the big mounds that are there, they did it all with horse and buggy. And here's their slag piles that have turned into mountains over time. That's a slag pile, by the way. That right there, giant slag pile, the whole thing. You could see? Yeah, they did that all with horse and buggy, you see? Yep. Earthquake right next to it. So 3.3 up here at Yellowstone, 3.2 down here at Long Valley, and then a 4. And this is a 4. Well, 3.9 USGS. But if you actually go look at the technical details on the page, or the origin information and magnitudes, you might find that there's a little variation on the stations. Taking it up into the 4 point something range, and they only show us 10 or whatever stations, as if that's all we have at TextNet. Okay, maybe we need to get a few more sensors out there in the fields. But the fields are pretty well populated by other things. Wait till you see what's here. If you're a new viewer, we're going down to Toyah, Texas. Oh, wow, look what we have right there. What are those tanks and pumps and jacks and pipelines laid out on the ground there? Well, the tubing is containing chemicals and oil and all kinds of stuff. They leave the tubes out on the ground so they don't bury them, so that they can see if there's a big spill. Because when you get this number of drill points along through here, you see them? These are all drill points. Every single one of these is an oil well, oil or gas well. You see the pipeline and tank and pump and jack and, okay. Anyway, when you start getting this number of drill points across an area, it can compromise the surface stability of the plate that you're doing it to. And this is the edge of the North American Craton that I already showed you like 4 times in this update. It comes down through Colorado. Here's Colorado. Goes down through New Mexico. Makes a bend and goes back up into Texas. Toyah, Texas. Earthquake right there. Edge of the Craton. It looks like a river, doesn't it? That's a 1,000-foot bulge. This is bulging right there. This is all 1,000 feet higher than down here. You could rise 1,000 feet across here. This goes up through Dallas. Here's Dallas. Goes directly through Fort Worth. Dallas-Fort Worth. And then makes a hard bend to the east through Arkansas. Then we make a bend like a letter N through the New Madrid seismic zone. St. Louis is up here. New Madrid is right here, just as a point of reference. So you see the edge of the Craton. And the 4 is over here in Texas on the edge of the Craton. So how did we get a 4 on the edge of the Craton and 3's out west? Go back a day. 1 day before. Look what struck just south of the U.S. border. Do you see it? It's the same sized quake, but it's out on the accretionary belt. It's out on the edge of the plate. So first, a 4's worth of energy came in on the edge of the plate. California, Mexico border. Then a 4 struck over the oil pumping operations within the day over on the edge of the Craton. Now there's something else going on where this 4 struck. down here in Mexico. See where it says Manadero? Manadero? No bueno, guys. I'm never going to be able to do it, man. Let's go over and check and see what's going on there. There's something else happening here next to this significant size quake in Mexico, right at the U.S. border. I'm going to turn on true color view, and we're going to zoom in real close as we can, right down here at the border. And right here, just east of this inlet, right there, a big series of fires have taken place over the past few days, and it may even be going on there last night. You can still see a little bit of the smoke. Oh, there you go. There's some of the smoke right there. This burning. So we've got fires going on right there. And again, I don't know if you'll see. Let me move it back and forth. You might not be able to see it. You would have to look close. They were way, way, way bigger the last couple days. Today it's looking like maybe they got a hold on it finally, or it's just burned through and burned out. Anyway, down there to the south, major fires, earthquake next to it. Now that goes back to the other fires and the other earthquakes next to the fires. How about the Hudson Bay? We got the fires going on up here in Quebec, then a rare 3.0 earthquake strikes in the middle of the Hudson Bay right next to the fire. Oh, actually, not middle. Right down here next to the fires, in the water. Just another example, and it's stuff I've told you to look for many, many years to tell you to look for, the fires and the earthquakes coinciding side by side. Now this gets me into the fires. Have you been paying attention? Up in Canada, we have a serious problem going on up in BC. The fires, different fires, broke out in central BC, and it's all of central BC. Look at these black dots. You see all these little black spots all over here? Let me take it back and show you. See all these? These are all fires right here. There and there across Alberta. But all of these in BC are somewhat, quote-unquote, new fires. This wasn't here back 2 weeks ago when I started reporting all of this. This is new, and it's insane. And I'm talking next level insane. We're going to go back and show you last night into today. So here's yesterday. That's all smoke. And here, let me turn on the natural color fire view so you can get a view of the smoke as opposed to the clouds. See the bluish kind of, that bluish haze? Okay. This is all smoke, the blue stuff. But this is not a natural view. I mean, this is, and that's the sun reflecting at sunset right there. Then there's our fires throughout the night, but we get a much better view on it on the actual true color, how it would appear if we were flying over from an airplane or something. It would look more like this. They would all look kind of whitish, but it's insane. Okay, so there's last night. There's the fires last night. Here's today. Throughout the day, you can see there's just huge puffs of dark smoke coming up from last night. And then throughout the day today, into the sunset now. It is 8:37 p.m. Central Time, which means it's what? 6:30 p.m. West Coast Time. And you can see the difference between the clouds, which are these white fluffy, and the rest of this, which is smoke. These being clouds over here on the right side, and clouds in the middle, and then the rest being smoke. This is BC. It's all of central BC is the way I would call this. When you look at the number of places that are burning here, if this is all of BC, 1/3 of BC, wouldn't you say? One quarter. 1/4 of BC is burning right now as we talk today, now, live. This is current right now. Now, that's just BC. When you look up here in Alberta, going further north up into Canada where we don't even really get a good satellite view, you can see we have smoke pouring in from up to the north. Now, the reason I'm taking the time to show this all to you is the Creighton Edge earthquake threat and the fire threat. These are many of these spots, not all of them, but many of them, are oil and gas pumping operations by the thousand. There are thousands and thousands of wells across this area in Alberta alone up here, let alone, I don't know what about in BC. We could go take a look just to take a general gander at the area. Gander in the United States means a look. Anyway, all through here is burning, but I'll turn on my place marks. See where it says oil and gas pumping? All of this up here is oil and gas. And I mean a lot of it. You go out in the back country and you get these remote roads that go out to all the pads. Do you see the pads? Hold on. They're low grain, grainy on purpose, so you can't see it. But you get the idea. These are all oil and gas pumping ops. Let me see if there is a higher resolution one that'll come up. I mean, I shouldn't need to prove this to you. You should be able to do the research yourself and go find it, but I understand a lot of people don't want to go look it up. Well, now this one doesn't have anything on it. That one right there. Of course, the one that they, wait, maybe this one does. Yeah, you can see the little build. Okay, they got a little shed in the building around the pump to protect it. All right, that's not going to do us much good to see the jack of the pump. This one doesn't have anything on it. Okay, well, I'm going to keep going until we find one that has one on it so I can prove my case, because there will be people here who are new who do not believe that these are oil and gas pumping operations. Dude, I'm going to keep going forever, however long it takes, guys. So, just hold on to your hats. It's going to take forever. I'm going to find it. No, these are all for forestry, Dutch. That's what it's for. They could have buried it. I suppose they could have buried the wellhead. Covered in snow. It's deliberate, guys. I stand by it. They're deliberately not showing the oil wells now. What is this? This is so bizarre. You zoom in on some. On the ones that do have something there, they're grainy as hell. There we go. There you go. Finally. Okay. So you see the white pill-like shape of some of the containers for gas that are there. That's not just a trailer or a shed. Although they are apparently building trailers and sheds around the areas to protect the jacks or pumps from the snow, like they do in Colorado and New Mexico. I've never really taken the time to zoom in and try and find one. This is annoying-ish. Okay, you can see snow-covered pipelines. For crying out loud, guys. Okay, Okay, we're gonna go. Should I edit this out, or should I leave this into my actual recording that I upload to YouTube? With the internet crapping out and me having to take 20 years to find a frickin' well, it's just getting pathetic. None of these have a well on them. None, not one. And the ones that do are grainy beyond belief. I can't believe it. You know what kind of time this would take to go through and make this actually, if it was like planned to be like that? Like some person would have to sit there and fish through all the pictures and say yep and nope on each one. I can't believe it. For crying out loud, man. All right, we're going further to the south. Finally. For crying out loud, man. Did they move the whole operation and just leave the old wells there, the old pads and the old pipelines? Maybe they did. Well, what are the chances a bunch of fires would break out at either one of them? It took that long for me to prove to you that the fires, and I have to prove it. You have to understand, I have to prove this to the viewing audience. I can't just say it. Why can't I just say it? When I can show you fires there, well, because people deny the fires. I'm getting people from Alberta and BC who are coming to my videos and saying that there are no fires and that there is no smoke and that I'm exaggerating. That was said to me yesterday by at least 10 different accounts. 10 different accounts on my community page alone denying that there's fires. In Canada, no smoke. Beautiful up here. Dutch is exaggerating. That's what they said. These are quotes now. These are quotes from yesterday. So what's going on up in Canada, man? There's something going on. Look over here in Quebec. Your perfectly natural, yearly, normal, freaking end of the world fires. Right? Oh, by the way, I'm loving the fire out there on the little island. You see that, the little island that's burning out there? Right there in the Hudson Bay. I'm really liking that one. Let's go out and see that little island that's burning. I wonder which one of these little islands here is on fire. One of them out there, east of the big one, is on fire right now. We don't have a localized sector as far as I know. We don't have a sub-regional sector, or do we? No. Not containing the spot that's on fire, the little island. We have to look at a separate side view. Yeah, it's one of the little. So there's something going on in Canada. They're denying the fires. The mainstream media came after me and freaked out on me for reporting on the fires. What's going on, guys? What's your deal? Somebody's got to explain what's going on. It's too weird. Everybody's freaking out for me reporting on it, but why? Like, you got to understand, Reuters, Canadian National News, France 24, all came stepping and smacked me in the face a couple times, called me a conspiracy theorist, and said that I said that it's a conspiracy that the fires are taking place. They said that I said that it's a conspiracy. What's your deal? I think something's going on with the plate. That's what I think. I think the plate's shifting along the edge of the North American craton. It matches interior and exterior portions of the craton up in BC, up in the Northwest, and up in the Northeast. On both sides of that brown-purple part, both sides are getting fires. That's what I think is the cause of the fires along the edge of the craton. Now, across the center of the craton, there's something going on across the rest of Canada, which no one's talking about as well. As far as I know, when you look at the view like this, you might not see it. Let's go look at the smoke view. Now you should be able to see it. The clouds are white. The smoke comes in right about there where it gets illuminated by the sun, and you see it. It's mixing in, and it's insane. It's going across all of Canada, Saskatchewan, Manitoba, and far north to where we can't even see it, like I said. Out off the view, up to the northwest, up in Yukon and the Northern Territories. It's next level as well now, beginning. So I have to make a big deal about the fires, and I didn't make a big deal about the fires at first. I reported on it, but then when the mainstream media piled on, dude, something's going on. Something weird is going on. And it's not climate change. Let's just let's crumple that up and throw it out the window. Climate change. Maybe from microwaves, human-induced climate change from radio wave devices, that could cause climate change across the planet. That certainly could. But that would be the only kind of climate change I'd be telling you would happen, is the climate change that would happen from human high-power microwave systems and high-frequency systems. And also low-frequency systems, too, if they're very powerful. And they want to manipulate large storms, be using low frequency as opposed to high frequency or microwaves. Well, anyway, we've got ourselves a problem going across the edge of the plate. And the problem isn't me reporting on it. Although they would like to think or tell the normie population that it is, the problem is the fires and them not ever happening like this before, at least in the 50 years I've been around. 47. The earthquakes going across the edge of the craton, matching where the fires are, cannot be overlooked at all either. And that's why I'm, again, stressing the earthquakes down in Mexico, earthquake up here in the Hudson Bay, and now we've got one of the little islands on fire next to where the earthquake struck last week. I think the fires could be caused
by seeping methane. There's frozen deposits of methane in the ground all the way from up in the Arctic North down through most of the United States, even off the coast out in the ocean of California and Oregon, and down in the Midwest United States, even down to Detroit and down to Ohio. Okay, huge methane frozen deposits in the ground on the East Coast too, over in Rhode Island and Massachusetts. The frozen methane, if the plate starts to heat up down below, many kilometers down below, I propose to you that when it turns to a gaseous state, will come up. I propose that when a hot gas gets heated, it will rise. And if methane heats and comes up out of the ground, all it's going to take is a little shifting piece of rock to produce a tiny spark, and you get yourself a fire breaking out along the edge of the craton. Not from magma coming up, not from lava seeping up, from deep heat down below that you wouldn't even be able to tell at the surface. And instead, methane comes up, seeps out, breaks out, boom, fires all over the place within a short period of time. Storms or no storms. People try to blame lightning. Look, you could try to blame lightning in every spot, but you sure are becoming a real lightning believer. Prove it, dude. Show me, man. Should be video of it somewhere. Lightning strike, a big fire break out, go across the entire countryside. I want to see it. Prove it. It's your claim? Stand by it. Prove it. Video or it didn't happen. Same for me on the methane. I've got video of the methane. I do. I have video of the methane coming up all across the edge of the craton. Northwest, Ohio, and northeast. So center of the craton, west coast, and east coast. I've got all kinds of studies proving it too. Anyway, let's go over on the west coast, take a look at the rest of the small quakes. Now that we've gotten the bigger quakes out of the way, and this update has lingered on far too long, me trying to find a pumping operation up in the northwest to prove my case that we're at pumping operations where the fires are. What about these stacks of quakes here? Washington State, Ashford, Washington. We're going to volcanoes, guys. It's about to be a volcanic update. We're about to go from talking about drill points and fires. We're going to go talk about earthquakes at volcanoes all the way down the west coast. Why are there earthquakes at volcanoes all the way down the west coast? Like, why are we striking down below Mount Rainier over and over again? Well, this wave that I talked about at the start of the update comes in and goes through the areas, and it vibrates through the magma chambers. When it vibrates through the magma chambers, guess what you get? Little swarms of earthquakes. Like over here at Yellowstone, when the waves vibrating over and going down to the edge of the craton. So over here on the west coast, over at Mount Rainier, that's where the stack of earthquakes is. There's one lone microquake inside the crater at Mount St. Helens, at the dome, the rising dome inside of Mount St. Helens. St. Helens blew in 1980 when I was a kid. Sent ash all the way over to St. Louis. This fine layer of ash deposited on the cars here. Anyway, Mount St. Helens. There you go. Right inside. Oh, did I say inside the crater? On the side of the crater. Over to the east, let's go take a look and see what's happening. Just some explosions. Some surface blasting, I guess. They're out there blowing stuff up. Let's go see what's there. Let's go see what's worthy of being blown up. It's good to know some responsible detonations going on out there next to the microwave towers. Yeah. You know what it is? Bubba got out there, decided it'd be a good idea, set up the targets right below the microwave towers. And then, boom! Explosion. Giant blast. Showing off for all his friends. You see that? You see that? Boom! What do we got going on over here? All right, look. You guys are weird, man. You guys are weird. You're just weird out there. We know this. It's already a given. It must be something in the leather of the Birkenstock sandals. Some kind of mind control shit. Pardon my language. Some kind of mind control stuff in there. Birkenstock sandals. Look, guys, you get an explosion down below your microwave towers. You got a problem with blowing stuff up. I mean, it's not an explosion below the microwave tower. What it is a seismic burst in the plate. Radio wave induced. How does that happen? Radio waves scuff their feet across the carpet of the atmosphere. You're all familiar with scuffing your feet across a carpet. You can pick up a charge in your body and go touch a doorknob or touch somebody, and out the charge comes out of you and goes into them. Zap, get a little lightning bolt. You act like a capacitor or a battery, and you store up that power. The same thing can happen with radio waves and the plate. The plate can store up power down below a transmitter or next to it. And it gets to a point where it discharges. Earthquake. Explosion, I mean. We get these next to power lines, power plants, whether they're solar, wind, geothermal, nuclear, coal fire, natural gas. So if it's generating a lot of power, we get earthquakes down below power stations. VLF, very low frequency, electrical. And it builds up in the plate, simply put. Let's go over to the east and look at this 1.0 over at Desert Air, Washington. The nice brisk desert air out there in Washington. It is desert-like. I don't know if you're going to want to get out here and start breathing the air. I don't know if you want to take a bunch of deep breaths out here. You know why? This place is called the Hanford Nuclear Storage Facility, or just Hanford. It's a Superfund site where they had all these experimental reactors they built during the Manhattan Project. They refined a bunch of uranium and other radiological materials. Well, it got out in a powder form. The millings, the shavings. What are you worried about? Anyway, you might not want to be breathing that deep desert air. Here is the LIGO Gravity Wave Sensing Station with its long lasers detecting gravity waves from across the universe. Across the universe. I wonder why they have it pointed at a right angle towards the heaviest elements on the periodic chart known to man. It's just chance. I asked. They said it's chance. They smacked their hands together like that, like they were dusting off their hands when they said that. Just chance. That's right. Chance. Project CHANCE cannot handle any more, I don't know, truth. We'll figure out an acronym for that. Chance stands for something. It means truth. So these long lasers go down and they actually have a scalar where they cross inside. They look for vibrations of the gravity waves. Never mind the earthquake there. And never mind the fires that break out around this place either. As a matter of fact, just never mind. Let's go up to the north and take a look at Entiat, Washington. You can just completely forget about that earthquake. I'm going to Obi-Wan you. Pull up in my hover car, wave my hand. These are not the earthquakes you're looking for. Drive away. Hover away. We're on the Columbia River, and we're next to Entiat, Washington. Now, there's something here just south. A hydroelectric dam. You see it there in the river. Now, the power lines come off of there and go up to the north. The reason I know this is a series of earthquakes have come from this dam and followed the power lines up this way and then jump across the river right about here. And guess what else jumps across the river and goes up this way? Look at that. High voltage power lines, the transmission lines, the big towers, not the kind that comes straight to your house. A lot of energy passing through these lines, very low frequency energy, and it comes from hydroelectric generation. Anyway, we've seen a series of earthquakes follow from this dam, back up and go across and out to the west, following the power lines. Down below, of course, down on the plate. So very low frequency induced earthquake activity. Down below power lines. Again, how many examples do I need to show you? This was all denied by professionals. Let's go up to Darrington, Washington. They said none of this was possible. The progression of earthquakes, the very low frequency earthquakes. I haven't even gotten into the solar storm or lack thereof. But solar storm activity also induces earthquake activity. Within 7 days of the solar storm bombarding Earth, well, actually, I'm sorry, within 7 days of being emitted towards the Earth from the sun, charged particles induce earthquake activity, deep earthquake activity. And then the deep earthquakes are followed by shallower, larger earthquake activity. If you see anyone claiming that solar activity does not cause earthquake activity, they are either mistaken or they are lying. And I saw a video from a guy with a big channel. I think he's mistaken. He just made his video a day ago. I think he's mistaken. I don't think he's lying. Although he has a scared look in his videos. So he might have an AK pointed at him or something, making him say it. Also, it's a look of guilt. But it also just might be a look of frustration, or it might just be the way the guy looks. I don't know. Denying earthquakes after the freaking solar storms? Are you serious? You guys still doing that? I didn't say that word. I did not. I almost did. There was no F in there. Out of Washington at volcanoes and nuclear test sites and weird places. Power lines, VLF, very low frequency. We go down over here, we're going to Yellowstone. That Mother Nature VLF wave going through the magma chamber there, swarming. So what do these locations all have in common? They're precipitation points. They're spots where the wave that's coming through this whole area is going to precipitate at all these spots. It's a giant, very low frequency wave passing through Washington, Oregon, Idaho, and Montana all at once. It's going over to the edge of the craton, like I showed you. And it's dropping off all these earthquakes along the way. Why at these spots? Well, they're weak points. They're weak points, where the wave seeks out. It's proof there's a wave. It's proof a wave is seeking out something, and it seeks out the weak points. Right? Like, these are all big discoveries that everybody denied, and like it was so basic that they overlooked, and now here we are. I'm in trouble for telling you, right? The conspiracy theorists for telling you that the earthquakes are striking at weak points. Dude, everybody needs to just back the hell off. Get the hell out of here, man. What's wrong with you guys? Not you guys, but everybody else. You know. When you speak in generalizations, you always have to say present company not accepted, so you can at least not alienate the people around you. At that time. We're on the edge of Newberry Crater. And we're on the edge of a bunch of power lines. I wonder why they put the power lines next to and through the lava fields and through the craters as opposed to around them. What would you do if I told you that someone at the power companies figured out a long time ago, I think his name was Ben Franklin, that if you fly a wire at a certain height above the ground, it'll collect energy out of the sky. Turns out it's just as high as a kite flies. Guess how high the freaking power lines are? No, they're as high as Ben Franklin flew his freaking kite. What are the chances? Oh, no. They need him above ground for ease of service, Dutch. Uh-huh. Whatever you say, Jeeves. Why do you put the power lines through all the megalithic sites like the Cahokia Mounds and next to the freaking pyramids? They need power at the pyramids, Dutch. A lot of tourists there. Over at Cahokia Mounds, too. They got a lot of tourists. Got to put the power lines there. That's why I put a railroad through it, too. You know what I'm saying? What would you do if I told you there's power coming up out of all these spots? People have been collecting it for a long time, going back to the Middle Ages. They used to build churches on top of it and put a Schumann resonance into it, a Schumann antenna into the church. Oh, God, we're getting sidetracked again, but I'm sarcastic about this stuff. I shouldn't be, but I am. Why? Everything I said was denied. I've had to prove everything too much. Now, when I'm forced to prove things, look what I do. Deep end off. Let's go take a look up the next earthquake. See what's there. We're going out of Newberry Crater. Going up here to the northeast. What's there? Is this an explosion of some kind? No, it's 2.7 kilometer depth. Washington Family Ranch. Never heard of it before. The Washington Family Ranch. Got a small earthquake down below it. Do we have anything else here nearby to justify the earthquake? To explain why it would seek out this point as opposed to any other? Is there any kind of power generation going on here that we need to know about? You would think that a facility like this would have its own power generation. There's an airstrip there, and it looks like we have a reservoir of some kind. I'm looking for power generation. Power generation. We're looking for the power lines. Gotta have. Oh. Okay, got the power lines. And where are they generating the power? Okay, I see some natural gas tanks. Power lines carry on down this way, following the road. Power generation is the key. We're right next to the power lines, so that kind of tells me that that's where it's coming from. I need to find this station. Once we find the station, we'll be able to see how far we are. It's definitely next to the power lines, so. All right, I'll find the station at some other point. I'm not going to go on a wild goose chase to find a power station when I'm right next to the power lines themselves. I'm just curious. I just want to know, is it hydroelectric? Is it solar? Is it wind? Where's it coming from? We'll answer that some other day. Let's go over to Estacada, Oregon. Paste and search. I smell coffee. The Duchess is brewing 9 p.m. coffee. Oh, my goodness. Gotta go get that. Okay, we're going to have to wrap up shop here in about a second, guys. All right, is there anything here nearby worth mentioning? Okay, all right. So, now this gets into the Boring Lava Field. The Boring Lava volcanic field underlying part of the city of Portland and neighboring areas to the east across the Columbia River in Washington was active from the Pliocene till about the mid-Pleistocene. The field consists of at least 32 to perhaps 50 small basaltic shield volcanoes and cinder cones. Okay. Am I proving my case that there's a reason for the earthquakes to strike at like 9 out of 10 of each one of these quakes? I still have so much more to go. Look, we have to go through all of California. Dude, this update is going to take forever. Forever. Let me just tell you, Northern California, Black Butte volcano going over here next to Silver Butte and Latour Butte, and north by northwest of Mount Lassen Volcanic Center. These two volcanoes. You can go look them up if you need to. Get the coordinates from the USGS, for crying out loud. Stop being so lazy, you damn Zoomer. Take your earbuds out. Take your earbuds out of your ear. Get off your hoverboard and get off my front lawn. All right, let's go over to the east. We have a ring of earthquakes going around the supervolcano, the other supervolcano, between Lake Tahoe and Pyramid Lake. There is a supervolcano that I had to discover myself and tell the world about. And how did I discover it? Earthquakes were striking around it. This giant oval shape here between Lake Tahoe and Pyramid Lake. It is lined with volcanoes, smaller volcanoes. Geothermal fields on both sides of it. Steamboat Springs and the Needles at Pyramid Lake. This thing. This is a huge ancient caldera. Fires break out around it. Volcanoes around it. Earthquakes around it. And today, last 48 hours, earthquakes around it. Going right into the middle of it. As we go down to the south, I shouldn't need to reiterate myself too much. We have the supervolcano at the California-Nevada border, the one that I showed you that's the confirmed supervolcano. Now, if you look from the supervolcano on the California side over to Monte Cristo, where that 3.2 is that I showed you at the start of the update, you'll see there's a rest of a bunch of smaller earthquakes making a big ring around the whole area. Just like up here, a ring around the supervolcano. It's like a child's song, a ring around the rosy. whatever that was. I don't even remember it. But so we have a ring of earthquakes around this, going from the supervolcano over to Monte Cristo and back through Mauna Loa. Ring around here and ring around here. Both supervolcanoes have rings of earthquakes around them right now. It doesn't mean there's going to be an eruption. It means there's a flow of seismic activity coming in across the craton right now. And seismic is about to go through the roof. We're about to take the step up, seismically speaking, over the next 5 days. Going into this coming week, we should see a big increase in magnitudes across the board in the United States. I'm thinking that we're going to go up by a full magnitude from where we are, a bunch of 4s, maybe even bigger, but 4s at least striking across the plate at all the spots where the 3s currently are, right next to them. Now, look at this stack of earthquakes down here in South Nevada. This swarm of earthquakes is down at a nuclear test site. Nukes. But we're not nuking there now. Don't worry, we're not doing nukes. They would be much bigger if we were. These small earthquakes are at man-made faults created by the blasts. And all the different blasts, I mean, there's so many. Here's the earthquake epicenter. Here, backing it out, just for a point of reference, Doomtown is right there. The valley containing all the underground nuke sites from the 50s, 60s, 70s, and 80s. And then the 80s and 90s nuke sites here, the ones we did with the French and the Brits. And we could click around on these if you need to see here. The UK, the Brits, came over and did Aqueduct Barnwell, December 8th, 1989, 120 kilotons. The Brits. The frickin' Brits. Mate, dude, you got a crisp with that? You know, we eat fries over here, guys. We'll call them crisps at the nuke site. Everything's crispy there. Chips and crisps. Okay, anyway. Go out of the nuke sites. We're going to go over to the east. We're going to go over into Utah, where we have a stepping stone path of the same sized earthquakes, literally the same size within a hair of a point, and going across to a volcanic field in Utah, coming out of Nevada. And what's in Nevada? Right here at the border? A lone earthquake. Caliente, Nevada. Hot. Spicy. Hot. What's there? How about a caldera? How about a giant ancient caldera? Do you see it? It's marked with Modena Draw, and it goes down across over into the volcanic fields down to the south at the Santa Clara Volcanic Cone. And it's in here. Wait, where's my place mark for it? Oh, interesting. I don't have the place mark for it. Anyway, you'll be able to see the old buttes and lava flows that make up the old center of the caldera there. I used to have it. Or wait, maybe it's covered. No, this is just for Santa Clara Cone. You're going to have to take my word for it. I hate it when people do that online. But this is confirmed an ancient caldera. I don't have the place mark for it. Okay. Get a name on it, right? Over to the east, we do have the place marks going across where the arrow is, southwest Utah. Turning back on our borders and labels just so you can see it. Wait. Well, I was zooming in on the wrong area. I guess that would help, right? This spot right here is an ancient caldera, and this one is as well. Hold on. I'm missing a bunch of place marks. They are not turned on. What is going on here? Temporary places? Well, I'm missing a huge swath. You can see the area where it's missing. All this area is missing place marks. It's not just a few, guys. I'm talking like hundreds of them are missing here. I don't know why they're gone. Sometimes the place marks will disappear if the server that's housing them from the Smithsonian or whatever is taken down or being taken offline. I can guarantee you there's a bunch of them that are supposed to be through here. Wow, this update sucks. This is probably my worst update in a long time. Or it's the best, depending on which way you want to look. It's the most real. Let's go up to the northeast. Dude. Elsinore, Utah. It's the most real update. The one where things go wrong, the one where I don't correct myself, the one where I take forever to look stuff up. The one where there are no place marks when you need them. Well, at least this is going to make it easy. We're next to a set of high voltage power lines going through the desert. Look at that. High voltage power lines going through the desert back up to the north. I don't see anything else there. What's the name of the nearest peak? Joseph Peak. Glenwood Mountain and Joseph Peak. What are we doing up on the top of Glenwood Mountain? Oh. Hey. I really like how Farmer Joe decided to get out there and do some wavy lines out there in the back country. I'm going to say it right now. This right here. I'm going to mark it. This is an ancient. They're either going to have to delete this or admit that it's something. Now that I'm showing it in video. Look at the coordinates. 3837 north, 11159 west. Or when you type it in, just type in 38 space 37 space N and type in 111 space 59 space W. Okay, and it'll bring it in on this. Okay, there it is. Weird feature. Not from farming or irrigation control. So we can rule out farming and we can rule out irrigation control at the top side of a peak of a mountain that doesn't go anywhere. We can also rule out skiing because there are no lifts or any way to get up these spots to go ski down them. And these are mounds, not tracts. I would say Native American ancient or hashtag Tartaria. Wow, on the top of Glenwood Mountain. The top back side so you can't see it from the town. Okay. We've gone on long enough, haven't we? Do I need to show you anything else? Californians are going to be like, hell yeah, you need to show us all of California, Dutch. How about this? Line of earthquakes going from your volcano down across the Bay Area, down to Parkfield and the oil pumping operations in the valley. And then the same sized earthquakes that are coming down the San Andreas pick back up down here at the south side of the valley and go back down to the southeast and go around this area from San Luis Obispo down to, well, let's see, what's the name of that place? Sorry. This place here, Concepcion, Lompoc. Sorry, I don't have that memorized. We come down and go, and this area is open on both sides of the San Andreas. North side, we're moving, jump over into the valley. What's there? Oil pumping operations. And I've got them marked so we don't have to go spend 100 hours going to try to find them. And you shouldn't need to take 100 hours to find them since there's a million of them going from here down along the San Andreas this way. And once you get down here, it's so overblown, the amount that there are, they begin to look, I mean, look at the mountain range there, right? It looks just like, it almost looks natural. But then you zoom in and you see these are all scraped out pads, and each pad has an oil well on it. You see, that's just the mountain range. They go right up to the San Andreas. Literally right up to it. Okay, anyway. What else is going on? We're down to Southern California. Our 3.0 level activity down at the border. Anything else worth mentioning? How about the lack of large earthquakes across the board in the United States? Lack of large earthquakes. Lack of large earthquakes everywhere. Lack of large earthquakes internationally. Lack of large earthquakes overseas. Lack of large earthquakes next to our deep quakes. Lack of large earthquakes in the middle of nowhere. I'm not going to say they've completely stopped. Last time I said that, 2 large earthquakes hit within the hour. Out in the middle of nowhere, nobody felt them. Makes you wonder if they were just throwing those on the feed, but still, no large earthquakes in areas where there are people. I'm getting suspicious. Something's going on with the planet. Something's changed. But what? Well, They said the inner core, or something about the inner core rotating changed direction. I don't know about all that. Solar activity, they said, is peaked. That the solar maximum reached us 2 years early. I'm face palming as I'm trying to maintain my composure telling you that. That's bogus, obviously. So the solar activity is picking up. The inner rotation of the Earth has changed. The weather's going ballistic, weird. And there's a lot of weather modification going on using high power systems like microwave. And to top it all off, in the news, breaking news for everybody who didn't hear, Elon Musk's satellites are leaking electromagnetic radiation. Leaking electromagnetic radiation. Low frequency. Uh-oh. SpaceX Starlink satellites are leaking electromagnetic radiation. Very low frequency. So now wait a second. They're using infrared lasers to communicate from satellite to satellite in space, the satellites. And they're using microwave to communicate from ground to space. Like your dish. Your dish is using microwaves to communicate. So how are the satellites producing low frequency? How are high frequency, very high frequency, ultra high frequency satellites generating low frequency? Well, there's only two ways to generate low frequency. One is with a very long antenna that's powered by a lot of electricity. That would be like something miles long, or at least thousands of feet long, to transmit very low frequency, as opposed to listen. To listen for very low frequency, you can use it with a smaller antenna. But to transmit it, that's why the U.S. Navy has these big, long arrays that are miles long and spread out across many, many miles, or many acres, or thousands of acres. The other way you can generate low frequency is the way HAARP does it, the High Frequency Active Auroral Research Program up in Alaska. HAARP. How does HAARP, the high frequency facility, generate all that low frequency that they brag about? Well, they generate plasma. What they do is they shoot high power radio waves up into the upper ionosphere, and way up there, where the radio wave is going, they get air glow, a pocket, a bubble, a ball of energy forms up in the upper ionosphere from shooting powerful radio waves up at the ionosphere. That glowing ball of air glow is vibrating, and it's many kilometers wide. And it's like a many kilometer wide bass speaker vibrating out very low frequency. That big ball up there that they're creating with the high frequency. So they use the high frequency to zap the upper atmosphere to create a big ball of vibrating low frequency. And they can turn it and adjust the way it points and vibrates out based upon the amount of power they put in at the array down on the ground. So now how can these satellites traveling through space, or up in the upper atmosphere on balloons, God knows how, up there, how is it generating low frequency? Well, now, I want you to imagine this here in this guy's hand is the antenna on the satellite. It could be however long, a few feet long, whatever. This thing on the satellite, and it's transmitting out high frequency, and it's moving through space-time. Or it's parked above the Earth, still, so to speak. Either way, guess what happens when radio waves scuff their feet across the carpet of the atmosphere? Air glow. Corona effect. Northern Lights. And I would propose to you that each antenna on these satellites, at least on this certain satellite, I don't know if maybe they fixed this problem, that the antenna itself, or the transmitter for it, the magnetron inside the satellite, would start to produce actual air glow. If you touched it, you would see little sparks on your finger. It wouldn't hurt. It would be cold, like plasma. But the sun is powering this, so it might shock you a little. You might not want to touch it. However, I would propose to you that the satellites up in space are producing low frequency by this process of efficiency scaling, of switching from low frequency to high frequency. And it happens as radio waves scuff their feet across the carpet of the atmosphere. Or in this case, the satellites are up in the ionosphere. In the upper reaches of the ionosphere, up in space, or up above the Earth, however you want to see it, electricity flows like being plugged into a wall. It's coupled, flows. So you can get vibrating very low frequency off these high frequency satellites. And what could that do? Well, low frequency is proved to have a few effects on things. Low frequency is proved to be in piezoelectric, whatever. Electricity in the ground is very low frequency. It's proved. It's an established fact. It's a few hertz per second. So I would say that this could have an earthquake effect. It also could have a weather effect. Guess what else has an effect? It has an effect on. Very low frequency can also have an effect on the weather. You can see these long waves spread out across hundreds of miles in the atmosphere, spreading out from storms. Very powerful electrically charged storms. You'll see it. The ripple effect. And it's not caused by wind. It spreads out too fast, too quick. Over the course of hours, it's spreading across 3,000 miles, going from a storm in the Midwest, and you see a ripple spread out and go all the way down to Mexico. In the course of less than a day, not even, few hours, you see that happen, a ripple. And it's not an atmospheric ripple from wind. It's an electromagnetic ripple that you can see in the storms. And you can see that now because of the new satellites. They didn't know this happened. It's new discoveries. So why does it matter if Starlink satellites are leaking electromagnetic radiation? Well, they're also putting out powerful infrared laser and powerful high-power microwave transmissions back down to ground. I would say it's all a bit much, radio-wise. I would say that if you start doing this all over Earth, like they are, that you would start seeing a bunch of weird weather. I would say it could lead to fires. I would say it would lead to drought and excess rain in spots. Because guess what? High-power microwaves are proved to create cloud condensation nuclei. And high-power radio waves in general strip actual electrons from the upper ionosphere and atmosphere, and they flow down. It's called electron cascade. Comes down from up above, raining down like small particles. And it acts like dust and attracts water molecules, but without any dust. The free ions, which they said couldn't happen. They said free ions couldn't be stripped from using radio waves. That was the old telecom studies from the early 2000s that Southwestern Bell telephone, Ma Bell paid for, the Bell system paid for, which they said that radio waves don't cause ionizing radiation at a distance. That's how everybody got brain cancer, and that's how you got Bluetooth headphones in your ears now. Bluetooth is microwave. Do you know that? Your Bluetooth headphone, microwave? Little microwaves going down in your ears. They say it's okay because it's low power, you see. Mm-hmm. Yep. Totally okay for you. I'm going to tell you a quick story. We're going to sign off. I worked for Southwestern Bell for several years back in the late 90s and early 2000s when they were rolling out the actual first round of Nokia phones and all the Motorola flip phones and the Razr phone and all that stuff. So right after the brick phone, right after the car phone, the big brick phone, the big ones, the big flip phones, the big chunky ones. Okay, right after that is when I started. It was the early 2000s. As they were rolling it out, they also had the Bluetooth headsets, the big ones that you put over your ear. People still wear them in their ears. And everybody was wearing the Bluetooth headsets. And then there was a court case that came out, and somebody had made a claim that they got brain cancer behind their ear from using the old brick phone. And Southwestern Bell and the telecoms decided to do a study to find out if radio waves could harm people. It took them a couple years to find out, and they said no, it doesn't harm anybody, and that there's no effect of your cell phone at all on your brain. Well, right after that came out, literally that week, the manager of the whole building, we had a building manager, we had a department manager, we had a warehouse manager. Okay, the big guy came through with a huge box of wired headsets, and he told everybody to turn off their Bluetooth headsets, stop using them actually in the stores, and don't use them as demonstrate for customers, and just to keep it on their ear turned off, and to wear these wired earbuds, and to always wear the wired earbuds. And all the managers there put the wired earbuds in and wore them the entire time I was there until 2006 when I left, and that was it. I left after 2006 and went out to Colorado and worked for T-Mobile. But anyway, before I left, before I worked for T-Mobile, right when I was getting ready to leave Southwestern Bell, 3 people in the building that I worked in, 3 got brain cancer behind their ears and died. All 3 of them died. So that study back from early 2000s where telecom said that wireless radiation doesn't cause cellular damage to animals or plants, and that wireless radiation, electromagnetic radiation, has no harmful effects, is a bullshit study. It's fake. It's wrong. It's false. They fabricated it. They made it up. They adjusted the numbers. I'm calling out Southwestern Bell and all the telecom, AT&T and all you guys. You guys are all full of shit. And you lied. And now that everybody's getting sick and you roll out more powerful systems, guess what exposure to high-power microwaves causes? Flu-like and pneumonia-like symptoms. That was the claim all the way back in 2000 that they denied. That was one of the claims. High-power microwave exposure causes pneumonia and flu-like symptoms. And that was denied by telecom, even though it was found to be true. And we all know this now. You can go look it up. So guess what's high power and at short range from you? 5G. And guess what microwaves do? They go into your nose and down your mouth, into your lungs and down your throat. They revert, like, think of a microwave like a vibration from a speaker, sound wave. And you have your mouth open, you're breathing. And guess what? Those sound waves go into your mouth and go down your throat. It doesn't mess with you or anything because they're sound waves. Right? You go to a rock concert and you're breathing. Guess what? Some of those sound waves are going into your lungs. Well, microwaves do the same thing. They go into your lungs. They don't come back out. They get absorbed into your lungs and into your bronchial passages, all those little cavities that are in there. And if you get exposed long enough, it fries them. Anyway, you guys, I think I will upload this. I told enough stories in here that it's actually offset the time that it took for it to go look up all the stupid wells and all the other stuff. That you get to learn something in this update about radio waves and how you were lied to by all the companies that stand a profit off the radio waves and the government that regulates it. They don't care. They believe that there's too many people. The government, the companies, all the leaders, all that. They all believe there's too many people. You can tell they've never driven across the United States, right? They believe there's too many people. There's so many open spots, non-farmable, that you could live in, right? Anyway, they believe there's too many. It's false belief. Incorrect belief. It's based on some 1800s stupid elite shit. Anyway, these people want to eliminate the population, so they don't care. They actually like that it does this stuff. Whoever they are, they're like dark-hearted people, whatever you want to call them. They probably worship some weird stuff. They probably worship themselves. Anyway, that's how you get it. That's how you get sick. That's how you get a world of sick people right after they roll out 5G. Blame it on some... Never mind. Never mind. You guys, do you have an earthquake plan? Back to earthquakes. Do you have an earthquake plan? You know what to do when an earthquake strikes? They called me a conspiracy theorist on all these things, including earthquakes. There's a progression of earthquakes that goes out around the planet. Now that you know that, you should be able to plan for earthquake activity based upon what's spreading out. You should be able to watch it and see there's 5s going out in one direction and 5s going out in the other. And see that 5s are heading your way if you live along the coast of the United States. Or see that 4s are heading your way if you live over in Asia. If you live in Hawaii, you got to see those 4s go a week. It took a week. Got to see those 4s go all the way up into Russia and then come down to you. It's like a river. This is not exactly a professional update. Like, if you listen back to this and you hear me talk, you might not think I'm the most intelligent person. And I'm not. I'm a high school graduate who made a series of unfortunate discoveries. I call them unfortunate because it's ruined my life. You think it would be awesome to discover that there's a flow of earthquakes, and you think everybody would be happy with you for finding out that earthquakes are striking between current earthquakes. You can figure out the middle points and stuff. No, man, everybody freaked on me. They came after me, burned me at the stake. I'm not kidding. Rejected everything I showed, denied it all, and here we are. I'm going to still broadcast to you and show it to you. Eventually they'll have to get on board, but whatever. Am I bitter about it? You're damn right. Let's save it and upload it. All the little imperfections, and put it out to the world. Peace out.